let's talk about how to calculate weight. Now, your weight is your force due to gravity, and it is not equal to your mass. Okay, your mass is in kilograms or grams, and your weight is in newtons or pounds. And your weight is not equal to your mass. Okay, and your weight depends on gravity. Okay, if you were to live on the moon, you would weigh less than you live here. I sometimes wish that my bathroom scale was like moon gravity in the bathroom where my scale is, so I would weigh less, and then the whole rest of my house can be regular gravity so I can walk around and stuff. But my bathroom where my scale is, I would like that to be moon gravity. That would be very nice because I would weigh less. And our formula for this is just our mass times acceleration. It's the same thing as this F equals ma, except in this one our A is gravity. Okay, and again, our gravity is 9.8. You guys should have this memorized. You will use this a lot this year. If you have not memorized it yet, now is the time. So let's solve a gravity problem. So we want to know, what is our weight? That's your force due to gravity. On Earth, if your mass is 65 kilograms, and then you need to use 9.8 meters per second as your gravity. So the things that we know, we do not know Fg. This is what we want, and it will be in newtons. We know that our mass is 65 grams. We know that our gravity is 9.8 meters per second squared. Our formula for this is Fg equals mg. Okay, we want Fg, so we don't have to put in the triangle or rearrange anything. So I'm just going to have Fg equals mass times gravity. My mass is 65 grams. And my my mass is 65 kilograms. Let me erase this. Our mass is 65 kilograms. That would have really changed. That would have been a really big person. Our mass is 65 kilograms, and our gravity is 9.8 meters per second squared. Okay. Again, in order to get rid of this, you want newtons on the top. So you can put newtons here, and 1 newton is equal to 1 kilogram times meters per second squared. And the second square goes on the top this time because the meters per second is on the bottom. And so, again, you don't have to do this part. I'm just showing you how the units cancel out. You have kilograms, you get rid of those. You can get rid of meters. You can get rid of seconds squared, and then you're left with newtons. And so your answer is going to be 637 newtons. When you guys do the elevator lab, you guys are going to have to know how to calculate your force due to gravity. That way you can solve the problems, because remember, your force due to gravity is equal to your normal force. So this is going to be really key. Now let's try and see what we would weigh on the moon. So this problem says, what is your weight on the moon? So your weight is your force due to gravity. On the moon, if your mass is 65 kilograms, and then you want to use 1.6 meters per second squared as your g. So the things that we know. We do not know Fg, that's what we want. Its units will be in newtons. We do know that our mass is 65 kilograms, and our gravity is 1.6. If on a test or something they ask you to do a moon problem, they're going to give you the moon gravity. The only thing that you have to memorize is gravity on Earth, which is 9.8. We can write our formula. Again, we're looking for this Fg, so we do not have to put it in the triangle. And so we have Fg equals 65 kilograms times 1.6 meters per second squared. And again, you do not have to do the conversions, but I'm going to do them so you can see where it comes from. Your newtons are on the top. You have 1 kilogram times meters per second squared. You can see your kilograms are going to cross out, your meters will cross out, your seconds will cross out, and you're left with 65 times 1.6, and you weigh 104 newtons on the moon, which is much less. Again, in this one, you do have to put units. If you don't put units, I will assume elephants. And you weighing 104 elephants really doesn't make a whole ton of sense. That would be a lot of weight. Okay, so this is how you calculate weight.